Sodium chloride is commonly used as a condiment and food preservative. It is used in injections and is a major source of sodium and chlorine compounds, hence used as feedstock for chemical synthesis. A second major application of sodium chloride is de-icing of roadways in sub-freezing weather. In this session, we are going to discuss the formula of a compound and the number of voids filled. Last class, we had discussed about the different types of voids, namely the tetrahedral voids and the octahedral voids. In this class, we are going to learn about the relationship between the number of particles forming the closed packing and the number of tetrahedral voids and the octahedral voids. Also, we are going to find out the formula of a compound based on the fraction of octahedral voids and tetrahedral voids occupied by the particles packing. Now, let us look at certain facts regarding the number of octahedral voids, tetrahedral voids and the number of close packed particles. First point, the number of octahedral voids present in a lattice is equal to the number of close packed particles. That is, if say 1,000,000 particles forms the close packing, then the number of octahedral voids present in the lattice will be equal to 1,000,000. Then the number of tetrahedral voids produced is twice this number. So the number of tetrahedral voids where 1,000,000 particles forms the close packing will be equal to 2,000,000. The third point, in ionic solids, the bigger ions, that is the anions, forms close packed structure and the smaller ions, that is the cations, occupy the voids. I don't have to explain why the anions are bigger and the cations are smaller. You have learned about the smaller cations and the larger anions last year. So, anions are usually larger compared to the cations. Hence, usually the anions forms the close packed structure, cations occupy the voids. If the latter ion is small, then tetrahedral voids are occupied, and if bigger, then octahedral voids are occupied. The latter ion here means the cation. We said that the cations occupy the voids. So, if the cation is very small, then the smaller tetrahedral voids are occupied, and if the cations are bigger, then the octahedral voids, which is larger than the tetrahedral voids, will be occupied. And in a compound, the fraction of octahedral voids or tetrahedral voids that are occupied determines the chemical formula of compound. Now we can solve certain problems and determine the chemical formula of the compound from the fraction of octahedral or tetrahedral voids occupied. So problem, let us read the question first. A compound is formed by two elements X and Y. Atoms of the element Y as anions make CCP, that is the cubic close packing, and those of the element X as cations occupy all the octahedral voids. What is the formula of the compound? So this is the problem. So we have been given two elements X and Y forming a compound, and it is mentioned that the atoms of the element Y are the anions and they make the close packing CCP, and those of the element X, they form the cations, and the smaller cations occupy all the octahedral voids, and we are asked to find out the formula of the compound. So let us take this case. The element Y forms the CCP. So let the number of Y particles be N. Then what will be the number of octahedral voids? It will be, I am marking it as O, the number of octahedral voids, they also will be N. It is said that element X occupy all the octahedral voids. So all the n octahedral voids are filled by the element X. So what will be the number of X? X also will be equal to n. So if we take the ratio of X is to Y, n is to n, that is 1 is to 1. So the formula of the compound formed by the elements X and Y will be XY. So this is the formula of the compound. Now we will move to the second problem. First let us read the question. Atoms of the element B forms HCP, that is the hexagonal close packing, and those of the element A occupy 2/3 of tetrahedral voids. What is the formula of the compound formed by the elements A and B? So the element B forms HCP. So let us first take the number of B. So let the number of B forming the HCP be n, and those of the element A occupy 2/3 of the tetrahedral voids. So first let us take the number of tetrahedral voids. T, I am marking it as T. So in any close packing, the number of tetrahedral voids will be twice the number of particles forming the close packing. So if n is the number, then 2n will be the number of tetrahedral voids. Now it is given in the question that the element A occupy 2/3 of tetrahedral voids. So what will be the number of the element A? So A is equal to 2/3 of n, 2n, that is the number of tetrahedral voids. Now let us take the ratio. So A is to B. A is 2/3 of 2n is to B, the number of B particles will be n. So that is n and n gets cancelled. 4/3 is to 1. So 4 is to 3. That is A 4 B 3. So this is the formula of the compound A4B3. Hope you understood. B forms the close packing. So let the number be n. Number of tetrahedral voids will be 2n. The number of A, element A, since they occupy 2/3 of tetrahedral voids, 2/3 into 2n. Now we take the ratio of the particles A and B. So the number of particles of A, 2/3 of 2n is to n, since B is n. So when we cut n, we get 4/3. So the ratio will be A4B3. So that is the formula of the compound formed by the elements A and B. Problem 3. An ionic compound crystallizes in FCC lattice, that is the face centered cubic close packing, in which A atoms occupy each corner of the cube and B atoms occupy the center of each face of the cube. Identify the formula of the compound. So this is a different type of problem in which we have to find the formula of the compound from a different information. That is, we are asked to find out the chemical formula based on the position of the particles occupying in the unit cell. So there are no voids mentioned here, only the position of the atoms A and B in the unit cell. Now let's try to draw the unit cell. This is the cubic unit cell. We'll mark the particle A with a different color. It occupies the corners. There are 8 corners and the 8 corners are occupied by particles A. We had discussed that the number of particles in a cubic unit cell in the primitive, face-centered, body-centered, end-centered, etc. and we can relate that information here. Since each corner is shared by 8 unit cells, only 1/8 of the particle belongs to this particular unit cell. So 8 into 1/8 equal to 1. So the number of particle A in this particular unit cell is only 1. Now the particle B occupies the faces. We'll take a different color. I am marking this face. At the center there is a particle. I am taking only this particular face because it will be confusing. And the face will be in contact with another face, which can be drawn like this. So this particle at the center of the face is shared by 2 unit cells. Like that we have 6 faces. So 6 into 1/2 is equal to 3. So the number of particles of B will be equal to 3 in the unit cell. When we take the ratio A is to B, we get it as 1:3. So the formula, the chemical formula of the compound will be AB3. AB3. So AB3 is the formula of the compound. It's based on the effective number of particles of A and B that belongs to a particular unit cell. So this is all in today's class. Have a nice day. Thank you.